If other universes exist, is it even possible to detect them? What created the fields and quantum fluctuations that supposedly set off the Big Bang? Could we use a long tether as a power source around Jupiter's strong magnetic field? And in Q&A Plus, what's the best way to watch a SpaceX launch? All this and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I'll answer them here. All right, let's get to the questions. Hemp freedom. If there was one or more universes beyond ours, would we be able to see them? So it really kind of depends on what you mean by behind and universes, I guess. Do we live in a multiverse? Do we live in, not just this universe, but are there multiple universes? And there are ways that you can actually have multiple universes in the universe that we have. So imagine, right, if the universe is infinite in all directions, then you will have sort of repeating circumstances. You'll have another Earth, you have another you. And in fact, you'll have an infinite number of Earths and an infinite number of yous. And so you will eventually have what is the entire observable universe repeated out there in the infinite actual universe. Is that a multiverse? If you wait long enough in time, we could very well have another universe. So that's another possible universe. But the one that you're probably thinking is the one that's sort of discussed in science fiction a lot of the time, where, in Stargate, there's a problem with the Stargate and they end up in this alternate universe where everybody's got little beards, right? Or maybe that's, the mirror universe in Star Trek. So one of the sort of ways to explain quantum mechanics is called the many world hypothesis. And that is that just, right now, when there are particles and the particles in decay, you sort of think about the Schrodinger's cat problem, right? That, you put this cat in a box, you put this particle in with the cat, you run the experiment, it either decays or it doesn't, and the cat is in this superposition, and you open up the box and then you see whether or not the cat is alive or dead. And that is the sort of the thought experiment. And in the many worlds hypothesis, instead, the universe splits into two universes, one in which the cat is alive and one in which the cat is dead. And so every time a decision gets made in this universe, it splits off another universe that is very real, like is as real as this universe. You happen to be in the universe that you're in, which is this sort of winding line through all of the decision tree that could have been made. But we wouldn't have any way to access or see or view that other universe. Another possible way that you could have multiple universes is there's this theory called inflation, which is, there's a lot of observational evidence that this is the case, that early on in the history of the universe, there was this sort of rapid expansion of the universe, and we've got a version of it that stopped inflating just moments after it began. But it's believed that there's other places in the universe where this, or in the larger universe, where this inflation is still happening. And that these universes are going to kind of overlap with each other, and could sort of, where they overlap, you get this kind of mass. And so in theory, if there were other universes that we were colliding with, that we might actually detect them, or maybe the collision would happen at the speed of light. And so the moment we experienced it, it was already over. So, there's a lot of sort of proposed ideas for how there could be other universes, and some we can hope to observe, and others are just beyond our ability to observe at all. Ed Skeptic, what created the fields and quantum fluctuations that supposedly set off the Big Bang? We have no idea. Nobody knows. Nobody knows what set off the Big Bang. That, astronomers look out into the universe today, they look and they can see that galaxies are moving away from us in all directions. And in fact, galaxies are moving away from each other in all directions. Space is becoming less dense over time, which means that if you run the clock backwards, space would be getting more dense over time. And you can then calculate when were the things that were on the right side of us that are now 42.5 billion light years away from us, and the stuff that's on the left side of us, it's now 42.5 billion light years away. I hope I did that right for you, by the way. I did these flipped around. Anyway, this is my right. But anyway, yeah. So the stuff that's 42.5 billion light years to the one side of us and the stuff that's on the other side were once in the same location. And when you do the math, that number comes out to 13.8 billion years ago. And we know, again, when we do the math, we know that all of that material was once so close, it was kind of like the surface of a star, sort of the density of the surface of the sun, for example. And that you would expect that this would be this place that you could see out in the universe at this time. And what do you know? We have the cosmic microwave background radiation. So that verifies that the universe was once at that density. But you can keep going and you can say, well, if the universe was expanding, then there was going to be this time when the entire universe was kind of like the interior of a star. And now a place that is so hot and so dense that you've got hydrogen turning into helium. And then you just have to calculate what is the percentage of hydrogen to helium, and that will tell you when that happened. And the percentage is about, say, 75% hydrogen, 25% helium. And you can calculate that, in fact, now we're back to just a couple of minutes after the beginning of the universe. And for like a dozen minutes or so, the entire universe was like the interior of a star. But physicists have these giant particle accelerators, so they can go even sooner. They know that at a certain point in the universe, various forces that are currently separate today, the strong force, the weak force, electromagnetism, gravity, were once combined forces. And they're able to, prove that this was the case in the Large Hadron Collider. And that gets you down into the first few just sub-seconds after the Big Bang, when the strong, the weak, and electromagnetism were all one thing. Electroweak force? No, there's another. Anyway, yeah, we still don't know how gravity works, but so on. And that allows you to kind of calculate this moment where all of this expansion began. And then there are some problems with the Big Bang. And so scientists have come up with a framework called inflation that explains some of those problems with the Big Bang. And that helps get you even closer to time equals zero. And in fact, there is observational evidence that this inflation period happened in the universe. But what happened before time equals zero? We don't know. What set these events in motion? We don't know. And we may never know. It could be that this is just a wall of our knowledge. Maybe when scientists figure out how gravity interacts and, there's a quantum theory of gravity that fits well with the other forces, that may get us a little bit closer. But whatever were the conditions that began this whole process, it is probably wiped out by the Big Bang itself. When you think about, imagine a hard drive, and you just go and you write ones and zeros into every single sector of the entire hard drive, and you completely wipe it. And then you put new data inside of it. What came before that? Well, you don't know. Those data are gone. Maybe if we're super lucky, there's some kind of echo in the universe today that we can then look at and say, okay, maybe that these were the conditions that led to the universe as we understand it. But, it's entirely possible that we will never know the answer to this question, that for the rest of intelligent civilizations from now until the end of the universe, or until the heat death of the universe, 5 quadrillion years from now, in some classroom, someone's going to ask, what came before the Big Bang? And the teacher, probably a robot teacher, is going to say, we don't know. We have no idea. And that's okay, right? I think that there are a lot of people who that is a very uncomfortable thing to hear, that they need an answer, and there has to be an answer, and that answer has to be knowable, and that there are all kinds of mythologies that have come up to try and explain what might be the unknowable. That when you sort of consider the Greek mythology or other mythologies, the Norse mythology, they come up with answers for where did the universe come from, and because we don't want to hear, we don't know. But sometimes we don't know is the only answer you can go with. And you can follow that with let's find out. But yeah, we don't know. It's time to shout out all the new $5 patrons and above. Jim Valentine, Paul W., Holger Dell, Nick Lindberg, Daniel, Jake Greaterix, Ray Latoul, Pranishka, Max Francis, and Jed O'Loughlin. Join the club at patreon.com/universe today. Dougal, do you think it would be feasible to use just a long tether as a power source for a spacecraft orbiting around Jupiter's strong magnetic field? So, wherever there are moving particles, there is energy. And so theoretically, if you had a spacecraft that was in orbit around Jupiter and it was moving through the magnetic fields of Jupiter, there is some way that you could extract energy out of that process. Whether you would be harvesting the currents that are generated by the interactions with the magnetic field, or whether you were trying to harvest the particles that are crashing into the spacecraft, there's like some way. Whenever there's motion, whenever there are fields, whenever there's magnetism, there's energy to be harvested. But it would be so hard, and it would be very little, and it just wouldn't be efficient compared to solar panels. We know that solar panels work at Jupiter. Now, they have to be 1/25th as much power for the same size. So Juno, if you look at the Juno spacecraft, it's got enormous solar panels. Same thing with the upcoming Europa Clipper mission. Huge solar panels. And that is because you've got 1/25th the sunlight on Jupiter that we have on Earth. So you just need 25 times as much solar panels, but it works just great. And solar panels are just like the nicest, stablest, safest, dependable technology. People are even working on solar panels for Saturn. In this case, you need them to be, and I forget what the number is, like 100? Like Saturn gets 1/100th the light that the Earth does, and yet solar panels would still theoretically work out at Saturn. Did you know you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A+. This week's bonus question, what's the best way to watch a SpaceX launch? And I'll put a link in the show notes. All right, those are all the questions that we had this episode. Thank you everyone who asked your questions into the YouTube comments, everybody who joined me for the live show. I'm going to give you some initial thoughts on Star City, which is a lot of people have been asking for this. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Progetti, Brian Bodie, Caradwin, Chuck Hawkins, Commander Baylock, Dark Finger, David Giltonan, David Matz, Enthralling Reading and Math for Toddlers, Evan.Pro, James Clark, Jeremy Mattern, Jim Burke, Marcel Smits, Michael Purcell, NASA Ocean Guy, Nordspace, OneStepAnimals.org. Please follow my nephew at VBrick6994, Rankaidu, Richard Williams, Sean Sargent, Stephen Filer Munley, Team 49, Telescopes Canada, Vlad Chiplin, Wolfgang Klotz, Zelda, One More Time with Enthusiasm, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So this is the most requested feedback on a recent TV show, and this is Star City, which is on Apple TV. And for those of you who are familiar with the story, or those of you who are not, Apple TV posted a new show 5 seasons ago called For All Mankind. And what For All Mankind did was it was sort of like an alternative history story about what would happen if the Soviets beat the Americans to the moon. And then instead of the Americans landing on the moon, coming back, and the Soviet N-1 rocket just exploding and them never putting people on the moon, there was an ongoing space race with both the Soviets and the Americans one-upping each other, trying to get to the moon. And For All Mankind is one of my favorite shows of all time, that it has a really accurate rendition of what the technology of spaceflight was like back in the 1960s and 70s, and then does a great job of extending that into what would the space shuttle look like, and then what would a mission to Mars look like in the 90s, and then a colony on Mars in the early 2000s. It's great. It gets a little weaker by the end of the season 5, but up until that point, I think it's absolutely required watching. And if you are in this space, you should be watching For All Mankind. Star City goes back to the beginning and looks at it from the perspective of the Soviets. And so in this same alternate universe where they have successfully landed a person on the moon, they moved to landing the first woman on the moon, and they have ambitious plans for the rest of the solar system. And it is, like, on the one hand, sort of giving you a fairly deep dive into what the Soviet rocket development system looked like and how the astronauts were trained. And it is just a totally different world than the way the Americans worked. It also just gives you this really compelling story of what it must have been like to live under the Soviet system. Just this constant surveillance and suspicion and paranoia and control over the citizens and the people who are trying to just build rockets and beat the Americans to the moon. And at the same time, everybody who's having their lives listened to, that every minor thing that you did could be the cause for suspicion and even execution. And look, I don't know how realistic that stuff is, but boy, as a story, it is incredibly compelling. And I find Star City is as good as the first season of For All Mankind was, maybe even better. I'm halfway through, so I'll probably give you another update when I finish the full season 1. But so far, I'm gripped, really enjoying it, and thanks everybody who was nagging me to watch Star City. So, Star City on Apple TV. All right, we'll see you next time.